Alright, so our next one here, again, I'm looking and I'm seeing is one the derivative of the other. So when I see this, once again, I see cosine is the derivative of sine. So sine will be my u, and cosine will be my du. So u is going to equal sine x and my du equals cosine x. Dx. So now when I do this when I rewrite this integral, it'll be the integral of u cubed, and this cosine x goes away, and it's just going to be du in its place. So now, just doing that simple power rule, reverse power rule, so I'm adding 1 to my exponent, and I'll get u to the 4th, and here, multiply by the reciprocal or divide by 4, so it'll be 1/4 u to the 4th plus c. I know u is sine x, so I substitute sine x back in, and I get 1/4 sine to the 4 x plus c. Alright. Last one here. So I look at this, and again, I'm saying is one the derivative of the other. There's more than one expression, so is one the derivative of the other. Here, I see secant squared. I know that this expression, secant squared, is the derivative of tan. So I'm going to make secant squared du, and I'm going to make tan u here. So u equals tan x and du, so my derivative of u equals secant squared dx. So I'm going to go ahead and substitute everything in. So integral, oh, that looks like an S. Integral of u, and this tan has this exponent, so it's tan squared, so it'll be u squared du. Once again, I'm just using my reverse power rule here. So I'm going to add 1 to that exponent, and I'll get u cubed. And I'm multiplying by the reciprocal, which is 1 over 3. And I'm going to say plus c on the end. Now, last thing I'm going to do is I'm going to put tan back in for u. So, be 1/3 tan cubed x plus c. All right. Moving on. All right. So this one here, it's a little bit different. So these last couple that we were doing, it was two things multiplying by each other. So we are seeing is one the derivative of the other. Now we're back to just one expression. So when it's one expression, it's our expression that's in our parentheses. So our exponent in this case is going to be our u. So our u equals 5x, and our du is just going to be 5 dx. So now I'm just substituting those in, because remember, d is the derivative of u. And I'll have the integral of e to the u du, and then the integral of e is always just itself. So integral of e is just going to be e to the u. Sorry guys, I did that wrong. I don't have a 5 here. I had to multiply by 5 on the inside, add the 1/5 on the outside. Apologies. So I'm putting the 1/5 on the outside, blah, 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 because I substituted the 5 and then dx for the du. So I have 1/5 e to the 5x plus c. Now, what I need now, if I look at this, it's like that first example that we did. I can just recognize whenever I see an e, kind of the shortcut is, whenever you see an e, just the antiderivative of e, if there's a constant in the exponent, is just going to be 1 over the constant, or the reciprocal of the constant, e, keep the exponent the same, plus c. That's all it's going to be. All right. Now, our last one, well, sorry, we have 2 more after this, but our last example for this slide. So we have 1 over 5x minus 2. Now, this is the same thing as the antiderivative of 5x minus 2 to the -1 dx. So when I do this, I can clearly see that I have an inside expression here. Remember, my inside expression here is going to be my du, or sorry, my u, and then this outside expression. So my u is going to be 5x minus 2. Then my du is just going to be 5 dx. So my derivative of this expression. So when I substitute that back in, I have the integral of u to the -1, so that was easy to substitute. And once again, I see I don't have this 5. So I'm multiplying by a 5 here and by 1/5 on the outside of the integral, so it equals 1. du. Now, I know my antiderivative, u to the -1. We can't use the reverse power rule because our exponent's a -1 here. The antiderivative of this will just be 1/5 ln. So ln or ln, the absolute value of u plus c. Last step, I'm substituting my u back into the equation, and I get 1/5 ln absolute value 5x minus 2 plus c. Alright, I'm going to upload this video and then there will be one more.